Arrays are a powerful tool for storing and manipulating collections of data, such as lists of items, results from queries, or even structured data. Understanding how to access specific elements from an array is crucial for effectively working with dynamic workflows. This flow will focus on demonstrating how to access the first, last, and custom indices of an array, handle potential issues such as out-of-bounds errors, and work with dynamic or changing data. By building this flow, you will not only get familiar with how to retrieve specific array elements, but also learn to handle common challenges that arise when working with arrays, such as ensuring the indices are within valid bounds. Throughout this process, we will be using compose actions to store and manipulate the array at different points. At each step, we will test the flow, and after running it, we will analyze the results stored in the compose action. This will allow us to observe how Power Automate interacts with arrays, how the array elements are retrieved, and how to handle potential errors that can occur when accessing out-of-bounds indices or dynamic data. By the end of this flow, you will have a deeper understanding of array manipulation in Power Automate, and you'll be able to confidently apply this knowledge to more complex workflows, ensuring you can access array elements efficiently and effectively. To start, create a new flow in Power Automate. Choose Instant Cloud Flow as the type of flow, as this allows you to manually trigger the flow. Give the flow a descriptive name that reflects its purpose, such as Array Element Access, First, Last, and Custom Indices. This name will make it easy to identify the flow later. After naming the flow, the next step is to set the trigger. For this exercise, choose Manually Trigger a Flow, since we will manually test the flow and its steps. Once the trigger is set, click Create to proceed. Now that the flow is created and the trigger is in place, you are ready to begin adding the necessary actions to manipulate and access array elements. The first action you will add is the Compose action, which will be used to initialize the array with data. This is the foundation of your flow, and it will allow you to start working with the array to test the different indexing scenarios. At this point, you have set up the flow, and you're ready to move on to the next steps, where you'll define the array and work with it. To begin, we need to initialize an array with structured data that we will later use in our flow. In Power Automate, we use the Compose action to define an array. This action will store a collection of information about individuals, each with multiple attributes. To accomplish this, we start by adding a Compose action to the flow, which we'll name Initialize Array with Data. This action is responsible for creating and storing the array. Inside this Compose action, we will input a structured JSON array that contains the information about 3 individuals. Each individual is represented as an object, and each object includes several key value pairs for various attributes. Once the Compose action is configured with this array, save the flow. This step ensures that the array has been properly initialized and contains the correct data. Now that we have successfully initialized the array with data about the individuals, the next step is to access the first element in that array. In this case, we are interested in the details of the first individual, John Doe. To access this first element, we need to use a new Compose action. This action will retrieve the first item from the array and display it, allowing us to use it in subsequent steps or for testing purposes. Specifically, we will be using array indexing to target the first element in the array. After the Compose action where the array is initialized, which we named Initialize Array with Data, add a new Compose action. This new action will be responsible for extracting the first element from the array we created earlier. To ensure clarity and easy identification in future steps, name this new Compose action as Compose First Element. This will help you easily recognize that this action is retrieving the first element of the array. Inside the new Compose action, we will use an expression to access the first element of the array. The expression we will use is Body of Compose, Initialize Array Index 0. This expression does 2 things. Body of compose initialize array. This part of the expression retrieves the content, the array, from the previous compose action, which is the array we initialized with individual data. 0. This part of the expression accesses the element at index 0 of the array. In Power Automate, arrays are zero-indexed, meaning the first element is at index 0. Therefore, this expression fetches the first element in the array, which is the data for John Doe. Once you've set up the expression, save your flow and then test it. After running the test, check the output of the compose first element action. The result should display the details of John Doe, as this is the first object in the array. The expected output from the compose first element action should look like this. This result confirms that the array has been correctly accessed, and that we have successfully retrieved the details of the first individual, John Doe. You can further use this data in the flow or analyze it as needed for the next steps. After successfully accessing the first element in the array, we now proceed to retrieve the last element in the array. This is useful when you want to access the final item in the list, regardless of the array's length. In this example, we will access Hannah Lewis's details, as she is the last entry in the array. After retrieving the first element in the previous step, you will add a new compose action. This action will be responsible for retrieving the last element in the array. Name this compose action compose talker last element, so that you can easily identify it as the step that retrieves the last item from the array. In the newly added compose action, we will use a dynamic expression to calculate and retrieve the last element of the array. The expression to use is Here's the breakdown of how the expression works. Body of initialize array with data. This function retrieves the entire array from the compose initialize array action. Last. This function returns the last item in the array, regardless of its size. It simplifies the retrieval of the last element, eliminating the need to manually calculate the index. Once you've configured the expression with the last function, save the flow and run it again. Then, check the output of the compose last element action. The output should contain the details for Hannah Lewis, as she is the last element in the array. The expected output will be Using the last function makes it much easier to retrieve the last element from an array in Power Automate. With this method, you don't have to worry about calculating the index or dealing with potential errors. This step successfully retrieves Hannah Lewis's details as the last element of the array. The flow is now able to handle array elements efficiently, whether accessing the first, last, or any specific index. There may be situations where you need to access an element in an array based on a dynamically set custom index. This step will guide you through the process of using a compose action to specify the custom index, and then retrieving the corresponding element from the array based on that index. The first thing we need to do is define the custom index that will be used to access the array. We will use a compose action for this purpose. After initializing the array in the previous step, add a compose action to the flow. In this compose, we will define the custom index, for example, 1. This index will be used to access the second element of the array. Since Power Automate uses zero-based indexing, i.e., 0 is the first element, 1 is the second element, etc. This compose action stores the value 1, which refers to the second item in the array. You can change this value to any other index dynamically during testing or to retrieve different items from the array. Once the custom index is defined in the compose action, the next step is to retrieve the element at that index from the array. The use of compose for the custom index allows you to adjust the index easily during testing and development without needing to modify other parts of the flow. When working with arrays in Power Automate, it's crucial to handle cases where an index might be out of bounds. The index is greater than or equal to the array's length. This can help prevent errors in your flow. In this step, we will add a condition action to check whether the custom index is within the valid range of the array. If the index is valid, we will retrieve the corresponding element. Otherwise, we will output a message indicating that the index is invalid. To handle the scenario where the index might be out of bounds, we'll start by adding a condition action right after the compose action that retrieves the custom index element. Add a condition action after the custom index retrieval step. In the condition, we will use an expression to check if the custom index is within the bounds of the array. The custom index should be greater than or equal to 0 and less than the length of the array. This combined expression ensures that we don't try to access an index that's out of the array's bounds, helping to avoid runtime errors. If the condition evaluates to true, meaning the index is valid, we will proceed with retrieving the corresponding element from the array. In the if-yes branch, when the index is valid, add a compose action to retrieve the element from the array using the custom index. Use the following expression to access the element at the custom index. Expression to retrieve the element. Outputs. Initialize array with data. Outputs. Custom index value. If the condition evaluates to false, meaning the custom index is out of bounds, either negative or greater than the array length, we want to handle this scenario by providing a clear error message or notification. In the if no branch, when the index is invalid, add a compose action to output an error message. For example, you can output the message to output, invalid index. This will indicate to the user that the index provided is outside the valid range of the array. Save and test the flow by using various custom index values. Test with a valid index, e.g., 1, which corresponds to the second element in the array. When testing with a valid index, the flow should retrieve the corresponding element and display it in the compose action of the if-yes branch. Test with an invalid index, e.g., 10, which exceeds the array's length. When testing with an invalid index, such as 10, the flow should output the message invalid index in the compose action of the if-no branch. By using a condition action to check the validity of the index before accessing the array, we ensure that our flow handles both valid and invalid indices gracefully. This method prevents runtime errors, providing a more robust flow that can handle various scenarios dynamically. The flow will either return the requested element or output a clear error message, depending on the validity of the provided index. In this flow, we have demonstrated how to work with arrays in Power Automate, focusing on 4 common operations: accessing the first element, accessing the last element, using a custom index, and handling out-of-bounds errors. Let's break down what each of these operations does at a high level. 1. Accessing the first element. This operation retrieves the very first item in the array. By accessing the first element, we can extract the data associated with the first entry of a collection, such as the details of the first person in a list. This is useful when we want to focus on or process the first entry in a dataset. 2. Accessing the last element. Similar to the first element, this operation focuses on retrieving the final item in the array. It allows us to work with the last entry, which can be particularly useful when dealing with data where the most recent or final item in the collection is important. 3. Accessing a custom index. In this operation, we retrieve an element from the array using a dynamic or user-defined index. By setting this index, we can access any element in the array based on its position, which provides flexibility when working with dynamic or unpredictable data. This allows for greater control and customization when extracting specific items from an array. 4. Handling index. Out of bounds. Finally, this operation ensures that we are safely accessing elements within the valid range of the array. It includes a check to validate that the index is within bounds, i.e., the index is not greater than or equal to the total number of elements. This prevents errors in cases where an invalid index is provided and ensures that the flow doesn't break or behave unpredictably when working with array data. Together, these 4 operations help you manage and manipulate array data effectively, ensuring that the flow can dynamically interact with any array and handle common scenarios like out-of-bounds errors. These techniques form the foundation for working with collections in Power Automate, enabling you to process and manage data in a flexible, error-free way. By ensuring that all steps are working correctly, you've successfully built a flow that dynamically accesses array elements using first, last, and custom indices, and handles potential errors gracefully. This flow demonstrates the core functionality of accessing and manipulating array elements in Power Automate. By initializing an array with structured data, we were able to use indexing to access elements in 3 different ways: first, last, and custom indices. Additionally, we introduced error handling to prevent issues when accessing invalid indices, making this flow robust and reliable for automation scenarios.